A very good evening, everybody, and indeed it is here at Gulf Harbour. Patricia and David, ZMH 286, and it is 0515 UTC, and we've got quite a full evening tonight. This is sort of the start of the first major burst of boats leaving, but we haven't got too many. We've only just got Gracias who left today, but we have got a bit to cover. We got a very, very interesting story. Well, it's not a story, it's a actual occurrence of a downburst in the Fiji area, kindly sent on to us by Camelot. It was from Ruffy on sailing vessel Wind River. And as we'd also had yesterday, a request to sort of explain the MJO, what it means to you when David says it's active. Well, what does that actually mean that you should be thinking about? There is, in fact, a paper on our website about the details of that, but let's go into the guts of, in summary, of what it really means, because there is an active MJO at the moment. So after I've talked to, well, maybe I won't talk to Gracias, because they've only just left, and also Zumax, David will cover the situation in the Southwest Pacific for those that are going to be on passage this week. And then he will discuss the MJO and talk about the very excellent treatise that Ruffy on Wind River has put together. Okay, I'm not sure whether we have Gracias on frequency, but let's give them a go. Gracias, Gulf Harbour Radio. As I say, they've just left, and in fact, on the way, are doing about 4.8 knots at a course of 237, having cleared out. So they're just at 1749 south and 17716 east, and 15 knots of southeasterly by the look of what's been experienced out there. So a pretty pleasant departure. Okay, Zumax, I know we usually leave you till later, but as David's going to be quite talkative tonight, I thought we would try you now. Zumax, Gulf Harbour. No, they're probably waiting till later. All right, let's. We have got boats that have emailed in, and I do appreciate that, to let me know whether you're leaving tomorrow or the next day or whatever. So let's have a listen to David to see what the situation is in your area.
Righto, we've got quite a bit to cover tonight. I hope it's going to be somewhat interesting, educational maybe. A lot of you know the details, I think, of what I'm going to say, but a lot of you don't. So apologies for trying to teach people how to suck eggs when they don't need to. So first we're going to start off with the synoptic analysis, and we'll talk about the subtropical depression, the one we've been talking about for the last week. That's been giving us all the grim weather that we've had. So anyway, the center, as of a couple hours ago, is located approximately 24 degrees south and 178 degrees west, and I determined that by satellite. Now, two troughs are visible with imagery from the center. One runs to Kandavu, so a little bit of an arc, if you will. The other, quite obvious on imagery, runs in an arc as well. It goes to Niue, then it curves over to Samoa, and then on to Tuvalu, and then on to the Solomons. Now that's the center of the trough. Now the cloud mass from this is very wide, so it's encompassing, when I say it goes to Niue and Samoa, that cloud is also covering Fiji as well. So you can see how broad this trough is, and the other one as well. Now, like I said, all of this is clearly delineated on the latest satellite image. A few of you have asked about that. So I'm taking this from Himawari 9 at 3:30 this afternoon, and you can find this on the internet. That's Himawari 9. It's a Japanese satellite, geostationary. So in these troughs, there are plenty of thunderstorms embedded, and we're going to talk for a little bit about that in a minute. But right now I'm going to talk about the weather in Fiji for those that are about ready to leave, or those that are not and are just interested. But anyway, here it is, and this is from them. A strong wind warning remains in force for southwest Viti Levu, Kandavu Passage, southern Koro Sea, and the southern Lao waters. Situation: a shallow low-pressure system is located to the south of Fiji, directing a southwest to a northwest wind over the group. The low is expected to drift southeast away from Fiji, and a southerly wind flow is expected to dominate the group from tomorrow. Note, a southerly wind flow. So that's more or less on the nose for those wanting to go south. So their forecast to 6 p.m. tomorrow for the southwest Viti Levu area, Kandavu Passage, and southern Koro Sea and the southern Lao, southwest to northwest winds 20 to 25 knots, rough seas, and a moderate southerly swell. Again, take note of the direction of the swell. The further outlook: southerly winds 15 to 20, moderate to rough sea, and moderate southerly swell. And the further outlook: southerly winds 10 to 15, not much in the way of wind speed, but the direction is not so hot. Moderate seas and moderate southerly swells. So that basically is why I suggested that people wait another day if they're going to go at all. And I'm referring to Fiji. Now, Tonga is a different story. There's, like we say, there's a lot of yachts in Tonga, and the situation there is quite different. So I will give you the forecast for the various island groups in Tonga. And the forecast then will start off with Tonga Tapu, cloudy periods with showers, a few showers, northwest winds 15 to 30 knots, 15 to 30 knots. For the Hapais, cloudy with a few showers, northwest winds also 15 to 30 knots. And for Vava'u in general, cloudy periods with a few showers, northwest winds, broken record here, northwest winds 15 to 30 knots. And for Niafu itself, rain, light rain, northwest 15 to 25 knots. So that's the story for the Tonga area, and I would suspect there aren't too many boats that are going to be taking off to go to New Zealand today or tomorrow or whenever, but you never know. Now, the Tasman Depression that I talked about yesterday, this is the one that is formed in the Tasman and heading toward New Zealand. It's still on track to affect New Zealand by next weekend. So that hasn't changed, and a variety of models agree with that, which is good. Expect the cold front over the North Island by Saturday the 26th, and that hasn't changed either. So it sounds like we could count on that happening. This will be preceded by the usual northerly quadrant winds, and after the front's axis crosses the top of the North Island, we should see 2.5 meter seas from the west. So that's on the other side of the front. Now on the east side of the axis, the seas are going to be 2 to 2.5 meters from the north. Now, as these two wave trains meet, I think we could expect sporty conditions. So be aware of that. The east side of the axis regarding winds, we're going to be looking at about 30 knots from the north. And on the west side of the axis, well, we'll see gale force winds. So the cold front is not trivial. It's not unusual either, but not trivial. So just certainly take care. And some slow yachts may elect to close with the front further north. They may slow down and just wait for it to pass. Now, the only issue with that, if you can call it an issue, is that the winds from the depression in the Tasman are going to be fairly strong as they come onto the North Island itself. Now, the center of that low it has gone to the south. It actually is going to make landfall in the middle of the South Island. But the northern and the western quarter of this depression, we've got some gale force winds. So what it's going to do come the 27th, 28th, 29th, I don't know. I wouldn't count on what the models are having to say. But there is a high to the east, and that's almost a 10:30, 10:29 on that date. This is Saturday the 26th. And then there's a high that's pretty much over Sydney, and that's 10:23 at the moment. Anyway, there's going to be a squash between that high and the Tasman Depression. So those isobars are looking very close together. So I would suspect that there's going to be a fair amount of wind that will continue to come onto New Zealand, probably westerlies. So those boats, if you did delay coming into New Zealand, it might not be so bad in terms of wind direction, providing the orientation of these two systems doesn't change very much. Westerly winds, even if they're strong, are not going to be too bad, particularly if you're coming in on the east side of the North Island, which most of you will be doing. So that is the synopsis, and so I have a couple of things to talk about. I'm going to give this to Patricia for a minute because I want her to tell you about this incident. It's really ironic. We talked about microbursts, and wouldn't you know it, but a yacht just experienced a microburst a few days ago. So here's Patricia for that. Then I'm going to come in and talk a little bit about them, what causes them, what to look for, that kind of thing. And then I'm going to talk a little bit about the MJO. So right now, here's the chief.
Actually, just a couple of administrative details before you all are rushing off tomorrow and the next day. Please, when you get near your destination, keep your AIS on until the satellite has actually picked you up. We, and also people like the RCC folk, monitor very, very carefully progress each day on boats, regardless of whether you're checking into us or not. And the last few days we've spent quite a lot of time because two boats turned off their AIS before they'd got to New Zealand, and it was very difficult to find out where they were they in trouble, and so on. Don't forget that the satellites do pass by, so if they happen to pass when you don't have a signal coming up, then they won't pick you up. And conversely, when you do send out, if some people I know with their AIS, they don't have it on very continuously to save power, so you might be emitting your signal when the satellites is not there. So it does take time, and I'm noticing this season that quite a few reports are very, very late. So please leave your AIS on until you're sure that the AIS has picked you up at your destination. That would be great. Now, also, there's a lot of emails coming in. As you know, we do live stream this broadcast, and some people will be emailing in their position, which I will be reading out because they have people following them who are interested, not just fellow boaties, but family and just people that seem to be interested in seeing what goes on in passage time, because they might be thinking of getting a yacht, doing a passage, or whatever. It's amazing how many people listen to the streaming. So I will be covering boats that are not coming in. But if you are just sending in your report by email, please make sure it's not just your position that we need, but we do need the actual wind speed and direction, not the apparent wind, but the true wind speed and direction. Because what David does is he looks at the different models he's using, he looks at what you say the cloud cover is, which helps him position fronts and the like, and he just checks out which is the model of the day, really. So if you are sending in a position, it would be good to get it by about 4 o'clock UTC time, because then it gives him a chance to have a good look through. Okay, and then lastly, he is going to go now onto the very excellent paper. He's called it The Anatomy of a Microburst, and it's just so timely. So thanks, Ruffy, if you're listening from Sailing Vessel Wind River. We've taken the opportunity to discuss that with folk, because, you know, it's all very well to hear about wind bursts in the Mediterranean, as we have had recently with the Bayesian, but to have it on our own backyard, in our own backyard, is rather sobering. So I'll pass the microphone to David to cover that, and thanks to Camelot for passing that on, and hopefully Rafi would agree to my putting it on the website so that you can read it at leisure.
Okay, just to give you a preview, if you decide to read this when Patricia puts it on, the microburst that he did receive, the speed was phenomenal. I believe
97 knots.
it was, what was it?
Went up to 97 knots.
97 knots. So it went from basically nothing, or
knots.
just normal knots. He was having weather, which was typical, but probably 25 to 30 knots, that type of thing. And then all of a sudden, here's 97 knots of wind, and it scared him too, needless to say. And it's a very good read. And this just happened a few days ago, so it's quite pertinent to what we've been talking about. So I think what I'm going to do, I'm going to explain a little bit about how a downburst forms, and then we'll talk about a few other things regarding downbursts and microbursts and that sort of thing. So anyway, we'll start by asking you to picture a very big thermal creating a large cumulus cloud. And you've all seen this happen. You've seen them build up, particularly if you're on land. Anyway, the cauliflower effect on the edge of the cloud is very evident, and I think you'll know what I'm talking about. So it just looks like the cloud's forming, and this cauliflower forms, and you could actually see the cloud actually just sort of rolling at the top and at 360 degrees. Anyway, as the thermal rolls in an eddy-like fashion, it winds up pulling in drier air that's surrounding the cloud. And when this dry air suddenly becomes entrained in the cloud itself, some of the cloud that's already there evaporates. This is just nature's way of equalizing the humidity aspect. So as the state goes from cloud to vapor, it needs heat. So it pulls heat from the dry air. This air is very active. The molecules are very excited. And anyway, this has a cooling effect. And the parcels now, as they roll into the center of this big cloud that looks like a cauliflower, these parcels are now very cold. and dense, much more dense than the rest of the cloud. And all of a sudden, gravity takes over, and this air then rushes to the ground as a gust, downburst, or microburst. So that's what happens. That's the nature of it. And there are uh, instruments that could monitor this sort of thing, which is quite interesting. So anyway, you're on your boat. So what do you look for on trying to figure out what's going on around you? So look for areas of intense downdraft in these clouds, and that'll be visible shafts of rain as you look outward from your position, wherever you are sitting in the cockpit of your boat. And we've all seen this. You see the cloud, and it looks like somebody's just poured water down, just a vertical stream that comes down. So that's the downflow. So use your eyes to see these rain shafts, if you will, for lack of better words, I suppose. So these microbursts last only about 2 to 5 minutes and are only about 1 to 2 miles, nautical miles, of horizontal diameter when they finally hit the ground. And winds have been recorded up to 170 knots. Now the winds hit the surface, and the minute they do that, they spread out in all directions. I have a kind of a silly little example of that. If you take a tall glass of water and hold it over the top of a table and just pour it down to the table, as that water hits the table, you'll see the water just spreads out in every direction, 360 degrees, and that's what the air does. Now, airports have wind shear detection instruments, and these instruments were developed probably in response to Eastern Airlines Flight 66, and this was in 1975. So this aircraft, this jet, was landing, and on landing was hit with a microburst, and it just crushed it to the surface. It was a fatal result for all aboard. Nobody lived. And other accidents are intensely evaluated because of that, so scientists can learn more and more about them and a better way to predict them. Another example, Patricia and I, by the way, are both pilots, and one of the things that we learned was to be very cognizant of landing when you have large CBs in the area. But picture this. Picture an aircraft on approach to landing. It may be traveling, a jet would be traveling at around 150 knots, a 737 as an example. That's about their landing speed. And suddenly they meet a microburst in front of them. And the wind from that microburst could wind up being 150 knots. And so what was a nice wind from the back, and the plane going at a very good speed through the air, finds out that there's no lift at all. It's gone, and it drops. The plane just drops down to the ground, plummets. And that's the end of it. So, yeah, that's what happens. So at sea, again, look at the vertical shafts of rain if it's daylight. Now your radar may pick up horizontal spikes of rain at the surface, if depending upon how good your radar is, I suppose. Now, quite a few vessels have fallen victim to these microbursts, and I have an example. An incident was the loss of the tall ship Concordia, and this was off Brazil in 2010. It was a tall ship, 188 feet long. It was a training vessel, had a lot of people on it, and it hit a microburst, or the other way around. The microburst hit it. It knocked this ship flat, and it sunk in 30 minutes. And I believe most of the people were saved in this particular incident. And most recently, the super yacht Bayesian, boy, this has created a huge stir amongst the super yacht people and designers and all that. Well, this Bayesian encountered a series of thunderstorms off Sicily, and they knew it. They saw it on their radar, and all of a sudden, there was a microburst, and it hit this yacht. This yacht is 184 feet long, and it laid it right over on its side, and it sank in minutes. On board were Mike Lynch. You may know he's a billionaire and whatnot. Patricia talked about this. Wife, daughter, and a total of 7 people died. Anyway, the yacht was built by Perini Navi, and it had the tallest mast in the world. Patricia talked about this yesterday. That mast was 237 feet high, so it acted just like a sail, and it just knocked this yacht over, and nobody knows exactly how the water wound up getting into that yacht, but that's the cause, or the start of the investigation, and probably lawsuits as well. So anyway, I talked about how the downburst can happen, and so we gave you a couple of examples of that, unfortunate as it is. So the last thing, just about the last thing, I guess, is we'll talk about the MJO cycle in the Southwest Pacific. Now that stands for Madden-Julian oscillation, and both Madden and Julian were research scientists, and they discovered this wave oscillation that travels eastward around the globe on an average of about 40 days. It was discovered by these two fellows in 1971, and they called it the 40 to 50 day oscillation. Anyway, cycles have varied from 30 to 60 days.
What does it mean?
Now, the MJO directly affects the weather for cruising yachts. So when the MJO is overhead, the yacht can expect light to very heavy rain and squally conditions. The downflow winds can be gale force and may certainly come from an inconvenient direction, making a safe anchorage into a lee shore. That happened to us once, as a matter of fact. In addition to direct effects, there is a major indirect effect for global weather as well. During heavy showers, a tremendous amount of heat is released into the upper atmosphere, and this affects what we call the Rossby waves. These are planetary waves, and these become the long wave pattern that affects all of our weather. So if the MJO coincides with the Australian monsoon, which it does from time to time, it's going to increase the monsoon effect. So those of you that are sailing up towards Indonesia and whatnot during the monsoon season, and you happen to experience an MJO cycle as you're doing this, it can be pretty exciting for a while. And if there is an existing quasi-stationary front or trough around you or near you, and this cycle starts to move over you, it is going to exacerbate the feature. So what was originally just a quasi-stationary front, the usual clouds, rain, some thunderstorms maybe, but the MJO is going to change that. And the most dangerous of all things that can happen is that the MJO can interact with tropical cyclones. They don't cause tropical cyclones, but if one happens to be in the process of forming and the MJO starts rolling in, then you are going to have an interaction, and that's not very pleasant. So where does it start, and what latitude and longitude is affected? So it begins its life in the Indian Ocean. It starts as a very small area of precipitation, of rain, south of the equator near about 60 east. it grows, and then it moves east, and it goes about 8 to 12 knots. So it's a pulse. So picture this thing, this pulse, moving about 8 to 12 knots. So it becomes then an eastward propagation of very deep convection and rain from the Indian Ocean all the way to the western Pacific. Now this pulse, this convective pulse and precipitation, from a cruising yacht's perspective, affects the area between roughly 10 north to about 30 south, and between the longitudes of about 150 east out to about 140 west. Now as that pulse continues to move east from 140 west, it becomes more or less nondescript, because it then moves over cooler waters of the eastern Pacific, and then it later reappears in the tropical Atlantic, and then finally back to the Indian Ocean, and that's the end of it, until another one forms. So I'm not going to get into the details of how all this happens, but that's what it is. And
it's active at the moment, is that right?
Yep, and at the moment, the MJO cycle is over the western north-south Pacific, north-south Pacific. That sounds pretty funny. But in any case, that's why I mentioned it, because we have so much activity. The troughing that we have been seeing over the last week or so has been exacerbated by this event. And those of you that are up in the tropics, especially the deep tropics, are getting wet. So that pretty much sums up what I have for you. I've got a few interesting things about clouds, but I may save that for tomorrow, because the chief is looking at me funny. So at least she didn't fall asleep. So in any case, here she is.
Well, thank you for that, and thank you for raising it. It's good to have a little weather lesson every now and again so that we know what's causing all the mayhem in the passage area. Right, so I'm going to go now, because I know that they're waiting, to Zumax. Zumax, good evening, Anna.
Hello, good evening. This is Zumax. I copied you pretty well tonight. Yesterday was very bad. And I give you my report. We are now at 2 degrees 4 minutes south, 135 degrees 28 minutes west. We are on a course of 015 degrees at a speed of 5 knots. We have about 12 knots of wind from the east, and the current is starting to get stronger, so it's started to get not to be pushed to the wind, let's say. But still fine now. We spoke with the boat that is in front of us. They just entered this morning the strongest equatorial current, and they're struggling with that, and they have about 3 knots of current going to the west. But here it is still about less than a knot at the moment. Over.
Wow, 3 knots, that's a pretty strong current, isn't it? Yeah, I'm glad you called in, because the AIS is very late at the moment. Zumax is 02 degrees 04 south, 135 degrees 28 west, on a course of 015 true at 5 knots, with a current against them, but soon to be an even stronger current. Stronger current, westerly current actually, 12 knots from the east.
I have a question for you.
So David has a question. Stand by, Anna.
Say, Anna, we haven't put you on a chart to see exactly where you are, but this current is that's phenomenal. When I look at the current progs on the internet. I've never seen anything like that except near atolls and that sort of thing, passes and whatnot. Are you out in the absolute total ocean, or are you near any islands or something that might cause that current to accelerate? I'm just curious. I've never heard of 3 knots before. Over.
Yeah, we are also curious to see what will happen. It's good to have a boat in front of us that is giving us already some information. And they are right now in the middle of that. And, well, of course, it's a much bigger boat than ours, so it's easier for them. They told me, they just told me a few minutes ago that they are saving and helping with the engine to keep at least north for it, so not to be pushed to the west. And the wind is good because they are having 15 knots of wind, so this helps to keep going north with the sails, even with the strong current. We should have more or less, because we will get to the equator tomorrow, and that's exactly where the strong current will start. And so yes, tomorrow, I think tomorrow, if the wind helps us now to get some speed, we should start that process that's tomorrow more or less at this time. Over.
Yeah, I've just put, for the interest of people listening, the boat ahead of them. I'm sure you're talking about Tomris. They're actually in the northern hemisphere now. They're 1 degree 48 north, and interesting that the 15 knots from the east looks like they've got, which is confirmed by you. And David has just said, aha. So I'm just going to pass the microphone again.
Yeah, shame on me. I forgot that you were right
So
around the equator. And of course, just north of the equator, you've got an east-going current that is, yeah, it's there all the time for the most part. It's strong sometimes and sometimes not. But that's the current that I try to encourage yachts to get into, to get easting before they go north, say to Hawaii or that type of thing. Pick up that current and let it give you a burst to the east. So yeah, there's a name for that. It escapes me right now. But yeah, that's very interesting. So well, that if you're going east with it, I guess that helps. Over.
We've been studying this current for a while now before starting this passage, and so yeah, we saw that it's very constant. Apparently, I mean, since we started monitoring it, it's very constant. It's going to be a struggle for about 3 to 4 degrees of latitude before getting out of it and find the countercurrent, which should help us then starting going east. So this is the plan. And yeah, from tomorrow we will start dancing. Over.
All right, so yep, we'll certainly be experiencing what happens around the equator. Okay, all right, well, good copy from you tonight, Anna, so that's good. We'll stick with this frequency again tomorrow. Hi to Paolo, and have a good night. Over.
Thank you very much. It's very nice speaking with you. And so yeah, tomorrow we'll try again at this frequency, and if it doesn't work, we can at the end of the next we can try on the other frequency you sent me. Over.
Yep, roger that. And I forgot to tell you and everybody else that probably knows already that New Zealand secured the America's Cup with another win today, which is their Saturday. So the America's Cup remains with New Zealand 3 times in a row, which is a record. but we still don't know where it will be next time around. We know it will not be in Auckland. The Auckland Council certainly can't afford to have anything like that, and we taxpayers can't afford it either. So it will either be still in Barcelona, which the Barcelonans are not all that happy about, or go to the Middle East. But anyway, at least it's secured under New Zealand's name. Okay, we'll clear with Zumax on their interesting trip, and we'll just see if there's anybody else on passage or wanting to check in. I know we've got a couple of radio checks to do, but before that, is there anybody wanting anything else other than a radio check? Well, I'm going to need some help. There is sailing vessel and something, and I can't quite pick it out. Hopefully you are on high power. Could you come again, please? Say the boat name a couple of times.
No.
No, I'm going to need some help. Anybody listening, and I know there are a few, you'll be closer than I am to it. Could you pick up that vessel, at least give me a boat name? Over. Nothing heard. Folks, to help you, we occasionally ask for some help picking up a boat. So if you can do that, it would be very useful. So sorry for the boat that's calling. If you are in a crowded anchorage, that might be what the problem is. But if you are at sea, that is a bit of a problem to me, because I would like to be able to pick you up. If you can send an email to ghradio@extra, which is xtra.co.nz. But otherwise we've got a bit of a problem with propagation. Right, let's go to see if I can pick up dash sailing vessel dash.
Info.
Oh, there's somebody there. It sounds like a familiar voice. Go ahead.
Yeah, thanks, Trish. This is Barry on Mackay. I think that might have been Andy on Soy Libre. I'd had an email from him, and we were going to try and meet on this frequency, and it sounded like him, but boy, was it weak. Over.
Yeah, thanks for that. I happened to see Soy Libre. They were heading southeast, I think. Soy Libre. If you could give us a couple of Roger Rogers, was that you?
Yes. Check in Soy Libre.
Oh, well, that was clearer. Thank you for that. Well, Barry, I got a 10 out of 10 for that one. Go ahead, Andy.
Yeah, I'm currently at Logos in DC, and my location is 19 degrees, 06 minutes, 1 minute south, and then 178 degrees, 34 minutes west. And the wind speed here is 12 to 15 knots. It's 12 to 15 knots out of the south. The barometric pressure is 1010. And I'm in a closed anchorage, so I can't say much about the sea state, but I will say that we've had some pretty crazy winds come through here last night. You know, they were 30 to 40 gusts. Over.
Wow.
Wow, okay, so Soy Libre just approaching the anchorage, 1506 south, 17834 west, with 12 to 15 knots from the south, and pretty crazy winds last night, up to 30 to 40 knots, 1010. What anchorage are you headed for, Andy?
I am in this anchorage. I'm going to be leaving, but the anchorage is 19 degrees, 06 minutes south.
Okay, got that. That sounds a bit more sensible. 1906 south and 17834 west, and you're about to leave. Okay, destination.
I'm looking for a window here in the next few days to get to Linda and General.
Okay, so you're going to be making your way to dinner over the next few days. Okay, all right, got that. And just stay online because it sounds like Barry is going to touch base with you. Alrighty, we're clear with Soy Libre. Was there anybody else wanting a radio check? Yep, I've got you, Dash, and it's a bit noisy when you key the microphone, but otherwise it's clear enough, Mike. So it looks like we'll have no problem, and you can confirm that you and Kelly are leaving tomorrow. Over. Yep, sounds like he's having trouble hearing, which I can understand at the desk where they are at the moment. There's a lot of competition around, but it sounds like we'll be able to hear you too when you get going, so that's good. All right, I'm going to vacate the frequency, folks. Thank you, David, for the little discussion tonight on microbursts and MJOs. If you want anything further on MJO, you can go to our website and click on weather and have a look at that, along with some other interesting stuff if you're not really busy getting ready to depart tomorrow or the next day. Okay, cheers everybody. We will be back again tomorrow, of course. This is Gulf Harbour Radio, clear, and it looks like the frequency will be in use between Mackay and Soy Libre. Cheers all.